Hey guys, it's Miss Gill. Today we are doing Module 11, Lesson 3. Our I can statement is I can apply the Pythagorean theorem to solve real-life problems involving the legs and hypotenuse of a right triangle, including problems in 3 dimensions. So there's our standard listed there for you. And today we're going to actually have to find square roots of numbers that are not perfect squares. So we're going to need to remember how to round using a decimal. All right, so if you're asked to find the tenths place, or not to find it, but to round to the tenths place, you're simply going to have 1 digit after the decimal. If you're asked to round to the hundredths place, you should have 2 digits after the decimal. And if you're asked around to the thousandths place, which I don't think this lesson does, but sometimes you are asked this, you would have 3 digits after the decimal. So sometimes we get confused on how do we know what to make that last digit if I'm rounding. So we'll do a quick example. All right, if we're using this decimal right here, 0.3462, and I want to round it to the tenths place. So I need just 1 digit after the decimal. So I'm going to look at the number to the next of it, and it's going to tell me what to do to this one. So in elementary school, a lot of your teachers taught you the jingle, 5 or more, let it soar, or let it raise the score, 4 or less, let it rest. So since this is 4 or less, we're going to let it rest. That means we're just going to leave it be. So this would simply be 0.3 if we rounded that decimal to the tenths place. All right, if we took the same decimal and rounded it to the hundredths place, we're going to look at the 6. The 6 is 5 or more, so it tells us to let it soar or to raise the score. So we're going to increase this by 1 digit, which is a 5. So then if we rounded this number to the hundredths place, our answer would be 0.35. And then if we did the thousandths place, we need 3 digits. So we would look at the 2 to tell us what to do with the 6. And since it is 4 or less, we're going to let it rest. So we'll let it be, and it's going to stay as 6. So that one rounded would be 0.346. So please don't let the rounding trip you up, because when you go to do the Into Math assignment that's assigned with this lesson, it could be a make it or break it answer. Like if you don't round correctly, then you could get marked wrong. So you just want to be careful and always reach out for help if you still struggle with rounding. All right, so we're going to move on to the lesson now. So here's our first question. I'm going to zoom out to make this picture fit in here. All right, so our first question says the red team and the blue team are playing capture the flag. Each team places their flag at opposite corners of the field. The red team sends 2 players, Alfredo and Angelina, from the red flag to capture the blue flag. Alfredo must follow the white arrows to the flag. How far does he run? So if we start at the red flag and we follow the white line this way, we know it's 85 meters because this measurement is 85 meters. And since this is a rectangle, those sides are exactly the same. So we know he first goes 85 meters. And if you need these pages, guys, you can pause the video and go print the pages out. They are located on the Files tab, and they are also on Focus under the Into Math assignment. So if you would like to have these and you have a printer, go ahead, pause the video now and print them out. All right, so he's now gone this way 85 meters, and now he's going this way, which is 150 meters. We know this because this side length is 150 meters. So if we take 85, we add 150, we get 235. So Alfredo runs 235 meters. Seems like a lot of work to go all the way out here and all the way down here when wouldn't it just be easy to go from this one to this one? So let's see if that's a quicker route. So our next one says Angelina must follow the black arrow to the flag. Use Pythagorean theorem to determine how far she runs. Round to the nearest 10th place. So that means we're going to have 1 digit after our decimal in our final answer. All right, so she's running this way. Remember, when we're trying to find the diagonal line of a right triangle, and this is a right triangle because it's a rectangle, and rectangles have 4 right angles. That is our hypotenuse, so we're trying to find the C. So we know our A value, we know our B value. They are given to us here. So we can write 85 squared, 150 squared is equal to C squared. So then take your calculator and square this number. So I'll grab mine real quick. So if you have a calculator like this one, you can, instead of doing 85 times 85, you could simply hit the square button right there. It's like the x raised to the second power, and it'll go ahead and square it for you. So they didn't really give us a space to write this, so I'm going to write it right here. 7225 plus 150 squared. But 150 squared is simply 150 times 150, and you get 22,500. All right, and so now to get this box here, we just need to add those two numbers together. So I'm going to add them together. And we get 29,725. All right, so now we just need to find the square root of both sides. So we know C is equal to the square root of 29,725. So now we're going to hit the square root button. So far we've just been trying to figure out which number times itself equals that. Well, this one would be a lot more challenging because they give us a hint that we're going to have a decimal. So I hit the square root button and it gives me 172.4093965. But I only want one digit. So I just need this 4, but I need to know, do I keep it a 4 or do I change it to a 5? So I look at the digit next to it. It is a 0. 0 is less than 4, so that means I let it rest. So my answer is 172.4. So you may notice that there is a squiggly line instead of a regular normal equal sign. So this means approximately or about. All right, so that means approximately or about. So Angelina runs approximately 172.4 meters, which is a lot less than Alfredo. So how much farther does Alfredo run than Angelina? So Alfredo ran 235 meters. Angelina ran 172.4 meters. So we just calculate that. So we have 235 minus 172.4. Oh, I forgot my point. Try this again. 235 minus, nope. There we go. 172.4, and we get 62.6. So Alfredo runs 62.6 meters further than Angelina. All right, so let's move on. Question 2. The Pythagorean theorem can be used to find links inside a three-dimensional object by finding right triangle relationships inside the object. So Jada wants to know, or wants to ship a 3-foot curtain rod to a customer. The biggest box at the post office is shown. Jada wants to know if the box is large enough to ship the curtain rod. So if Jada puts the curtain rod in this way, we're trying to figure out, would this box be big enough to fit the curtain rod that's 3 feet long? So they tell us that the measurement of this side of the box, so the height of the box is 30 inches. The measurement this way is 12 inches, and this way is 12 inches. So if we're trying to figure out this line right here, we need to at least know the measurements of the legs. So we need to know the height, which we know is 30 inches, and we need to know this measurement here. But we don't know this measurement But what we can do is use a triangle relationship to find it. So let's start with answering some of these questions. The longest distance in the box is the diagonal AD between opposite corners. So they're saying the longest distance is right here. It forms the hypotenuse of triangle ACD. What is the length of D to C? So from D to C, what is this measurement? Well, we know it based on the height of the rectangular box. If one edge of the box is 30 inches, every edge of the box is going to be 30 inches. All right, so then it says to find the length of AD, we must know the length of AC. So we got to know this length too. Look at the bottom of the box. Line AC is the hypotenuse of another right triangle, ABC. So AC is the hypotenuse of a triangle that's located right here. It says use Pythagorean theorem to find the length of AC, round to the nearest 10th place if necessary. So they've kind of drawn a bigger diagram of the bottom of the box for us. So we're trying to find this measurement right here. And since it is a diagonal length of a right triangle, we know it's a right triangle because it is a square, because it's a 12 by 12, or a rectangle, we know they have 4 right angles. So now we're just going to substitute our information in here. So we have 12 squared plus 12 squared equals c squared. So if I work out 12 squared, I know 12 times 12 is 144. And if I add those two together, I get 288. And so now I just need to find the square root of 288. So pull out my calculator, put in 288, hit the square root button, and we're going to, in this situation, we're going to round to the nearest whole number. So since it says 16.97, we're going to round to 17. If it had told us tenths place, we would look at the 7. The 7 would make this 9 turn to a 0, which would in turn change this to a 17. So the square root of 288 is approximately 17. So the length from here to here of AC is 17 inches. All right, so it says use the length of AC to find the length of AD. All right, so now we know that this measurement right here is 17 inches. So we know this measurement is 30, so both of the legs. We have 30 inches for one leg, 17 inches for the other leg, and we're trying to find the hypotenuse. So that's what we're going to fill in here. So the measurement from A to C we just found is 17. From C to D we said is 30, and then we're going to square them. So if we do 17 squared, we get 289. 30 squared, we get 900. And we add those two together, we get 1,189. So now our next step is to find C and not C squared. We need to take the square root of 1,189. So if we put that in the calculator, hit the square root button, we get 34.4818 and so on. If we look back to the beginning of the problem, it told us to round to the nearest tenths place. So if I just want one digit after the decimal, I'm going to look at the number next to it. The 8 tells us to raise the score. So I'm going to turn the 4 and increase it one digit to a 5. So it is approximately 34.5. The length of AD is about 34.5 inches. So now we know that this length from the corner to corner is 34.5 inches. About how long is the longest rod that could fit in the box? So if she's going to insert a rod in here to fit in the box, it can't be any bigger than this measurement here. If so, it's going to stick out the corner. Could it be smaller? It sure could, but it definitely can't be bigger. So about how long is the longest rod? It would be 34.5 inches. So then it asks us, can the curtain rod fit in the box? Why or why not? So let's look and see. In the beginning, they told us that she wants to ship a 3-foot curtain rod. So how many inches is 3 feet? Remember, there's 12 inches in a foot, so 3 times 12 equals 36. So the rod is 36 inches long. We found this diagonal to be 34.5 inches, so she could not put a curtain rod in there that is longer than 34.5 inches. So that curtain rod would not fit in this box. So the curtain rod would not fit because the longest rod that can fit in the box is 34.5 inches. All right, let's move on. We got one more step it out question and then a check understanding. All right, so Kara measured the radius and outside length of an ice cream cone. Identify the right triangle in the cone, then use Kara's measurement to find the height of the cone. Round your final answer to the nearest hundredth place. So far we've been doing tenths, now we're going to do hundredths place. All right, so this one's a little different because here's our right angle right here. So we're given one of the leg lengths. We don't know the other leg length, but we're given the hypotenuse. So this would be one where we're trying to find another leg length. So we're going to plug in the information that we're given. We know one leg is 2.5, and then we know the diagonal length of the cone is 11.7. And so then we're just going to square them. So let's put that in the calculator. If we do 2.5 squared, we get 6.25. If we get 11.7 squared, or 11.7 times 11.7, you get 136.89. So now with the legs, the way that they're different is we're not going to add these two together because we don't know B. We can find B if we subtract 6.25 from the hypotenuse. So we have the hypotenuse squared is 136.89 and the leg squared was 6.25. So we're just going to subtract them. And we get 130.64. So then we need to find the square root of both sides. Hit the square root button. Remember it did say round to the hundredths, so I need 2 places after my decimal. So then I'm going to look next to the 2. The 9 tells me what to do to the 2. Since it's 5 or more, I am going to raise the score. So it would be 11.43. So the height of the cone is about 11.43 centimeters. All right, so I want you guys to pause the video, and on your notes, if you have them, or on a sheet of paper, I want you to work out these 2 problems. Once you finish working these 2 problems out, unpause the video and see if your answers are correct. If you haven't already, please pause the video now because I'm about to go over these 2 questions. All right, so I hope that you gave them a try and hopefully you got them correct. So it says computer monitors are measured diagonally from corner to corner. If the rectangular screen of a 40-inch monitor is 35 inches wide, what is the height of the monitor? So we know the diagonal distance is 40 inches and we know that it is 35 inches wide. So we're trying to determine what is the height. So in this situation, you're looking for a leg. Let's start off with Pythagorean theorem. Go a squared plus b squared equals c squared. We know c is 40, and we know one of the leg lengths is 35, and we're just trying to find the other leg length. So we do 35 squared, so 35 times 35, we get 1,225. And then if we do 40 times 40, we get 1,600. So now, because we're looking for a leg, remember we subtract. So b squared equals 1,600 minus 1,225. So let's work that out. Whoop, I didn't mean to do that. Okay, and we get 375. So b squared is equal to 375, but remember we don't want b squared, we want b. So we find the square root of both sides, hit the square root button, and it said round to the nearest tenths place. So I need one digit after the decimal. I have a 6 after the 3, so 6 tells me to round up, so I have 19.4. So the measurement of the height of the computer monitor would be 19.4 inches. All right, so now a 20-inch rod fits perfectly in a box 15 inches tall. What is the measurement of x in the diagram, round to the nearest tenth? So we know the height is 15 inches here, so that means it is also 15 inches here. The distance from one corner to the other corner we just saw in the curtain rod example is a diagonal line, so this would be our hypotenuse. So they tell us our hypotenuse is 20 inches. We don't know the measurement of this leg. All right, so what we can do though is set up our equation to solve for a leg length. So I'm going to separate this one off so we don't get the work mixed up. I'm going to start this one underneath. All right, so we have a squared plus b squared equals c squared. We're given the c is 20. We're given one of the leg lengths is 15. All right, so now we just need to square them. So 15 squared gives us 225 plus b squared equals 400. So remember, when we're looking for a leg, we're subtracting. I'm going to move this over to here. So b squared is equal to 400 minus 225. So our handy dandy calculator, do 400 minus 225, we get 175. So b squared is 175. Remember, we don't want b squared, we want b. So we have to find the square root. It said round to the nearest tenths. So I have 13.22. Since the digit after the 2 is a 2, that tells us to let it rest. So b is equal to 13.2. So what is the measurement of x in this diagram? X is equal to 13.2 inches, and that would be your final answer. So guys, I hope this helps. If not, you can always join me for other live meetings so that we can go over any questions you have. You can also reach out to me if you need to get more practice or you just want to make sure you're doing it correctly. All right, guys, good luck.